All right, CNT 125. We're now digging into the new stuff in Chapter 8. One of the first things Chapter 8 mentions to us is about segmentation. Network can be segmented or broken into pieces, either physically by creating multiple LANs with things like different devices, or logically through the use of things like VLANs, virtual LANs. We are going to work into virtual LANs later in this chapter, so just stick that in the back of your brain that that's a logical way to break up a network, as opposed to physically with devices like routers and that sort of thing. Either way we do this, we can take a larger broadcast domain and break it into smaller pieces, which we need to do. If we let our network get too large without any kind of intelligence in there to break up the network, certain protocols just kind of get replicated on and on and on and on and on, kind of like, a bad rumor or something like that. So at some point we do need to put some boundaries around parts of our network, and that might be around the floor of a building, or around the building itself, or a particular room or a particular department, but we need to somehow contain some traffic that it does not spill out everywhere. That's the idea behind segmentation. Either way we do it, that larger broadcast domain is divided into smaller segments, and oftentimes the IP address is also subdivided as well. So two important ways that I can segment my network is through the use of subnets, taking a group of IP addresses, layer 3, and saying this group is kind of like this department or this part of the network, or this branch of a campus or branch of a company. That group of IP addresses would be a subnet. That is a layer 3 solution. The other important way to segment is through use of virtual LANs. In this case, I'm going to take a group of ports on a switch and put them together as a group, a logical grouping. That would be a layer 2 solution. You oftentimes see people talk about one or the other, but in reality, these usually do work together. Subnets and VLANs often do work together. I've been known to, when I do interviews, often ask this exact question: tell me the relationship between subnets and VLANs, because there is a relationship there, and they often do work together in networks. That is very common. So segmentation, taking a large network, divided into smaller pieces. As we said, we need to do that to kind of contain some traffic, keep some traffic maybe separated from other traffic, maybe wireless users separated from wired users, maybe IP phones separated from wireless users, that kind of thing. So you have to break the network up into some logical pieces. That way it's each its own broadcast domain, which I'm going to hit with you in just a minute here. And this accomplishes a couple things, helping with security. As we said, I'm keeping the wireless users separated from the wired users, or wireless users separated from the IP phone traffic, that sort of thing. This can also help improve performance, because again, if I keep my phone traffic away from my regular ordinary data traffic, I can allocate some better quality of service to the phone traffic, or better bandwidth, than I can the other traffic, to make sure that those phone calls are not choppy or delayed. This can also help with troubleshooting, because I know if I'm getting problems from a certain group of IP addresses, a certain subnet, I know it might be that subnet has an issue, whether it be on the switch or the router or whatever it is in that part of the network. That at least gives me an idea all my problems are coming from there. That's where I'm going to start my troubleshooting. Not uncommon. Networks are commonly segmented according to one of the following, and I've actually mentioned a couple of these already. Geographic locations, maybe a floor of a building. This entire floor, maybe where all the student computers and student labs are, we'll just break that up, and just that whole floor is segmented. It might be by departmental boundaries. Certain departments of a company might be grouped together. People that deal with payroll, we might group them together because they're dealing with a lot more sensitive data than other people are. So we'll control that traffic in and out. Device types could be desktops, wireless users, IP phones. I might group them and separate their traffic out, that they're not mingling with each other, if you will. Okay, all different ways I could segment. In some cases I might use all the above too, depending on my network. Now, before we go too much further, this is a concept from way back when, I think kind of thrown out very quickly with you in one of the 120 chapters. I'm trying to remember which one, but they mentioned collision domain, broadcast domain, and they showed a picture like so. So let me just kind of sort it out real quick. If you remember when we first started talking networking, when we had the bus network where data was getting shared across the bus network and it went to everybody, that was a network where there was no intelligence, no devices to control traffic. So in that case, you know, that early Ethernet bus network, there was chance for many collisions. There was nothing controlling who went first, who went second. So that whole big network was a giant collision domain. That's the fancy name. In other words, all those things were competing with each other and colliding with each other. So the bandwidth to each one of those was really low and really horrible. If I start adding layer 2 devices or higher, layer 2 device like a switch, want to add that layer 2 device or higher, I'm adding intelligence, and this is a good thing because I'm reducing the number of collisions, and when I reduce the number of collisions, I'm reducing the number of people competing for the bandwidth, so therefore nodes are getting more and more and or full bandwidth because I've added some intelligence. So when you take a look at a picture like this guy here, there we go. When you take a look at a picture of this guy here, if I go back to the old hub networks were layer 1, no intelligence. All those devices plugged into the hub are sharing that hub and sharing that bandwidth and colliding with each other. Hence, the bandwidth is horrible because of all those collisions and sharing. When I start adding layer 2 devices like this switch, you'll notice they put a bubble around each one. Well, each device is connected to a switch port, and if you remember, the switch builds a table of MAC addresses, and it tries to send data to only one node, only one port. Collisions essentially go away. I'm not going to say they go away totally, because there is the occasional, it does happen, blah, blah, blah. But for the most part, the majority of the collisions go away. These devices are getting pretty much direct connection and full bandwidth. So therefore, if I go back here, adding these layer 2 things and creating more collision domains is a good thing. Each one of these devices now is getting, coming back here, each one of these devices plugged into a switch port is getting full bandwidth. It's not competing with anybody. Hence why there's a bubble around every single node here plugged into a switch. That's a good thing. That's a good thing. Okay? Those nodes are getting, 97% of the bandwidth. That's around the ballpark you get. Meanwhile, there's a thing called a broadcast domain, which this chapter is kind of throwing out to you. There are protocols out there and things out there that are going to broadcast by default. You can't change that. They just happen. So if I don't contain them, those broadcasts are going to keep propagating and spilling out. Almost like spilling a massive bucket of water in the middle of the kitchen. If I don't contain that with some towels or something, it's going to start spilling under dishwashers and refrigerators and stoves and everything else. I throw a towel down and contain that so that it does not spill all over the place. The same thing is true with broadcasting a network. If I don't put a fence around part of my network, those protocols are going to broadcast and just keep going and clog up my network. So to do that, I need devices with some intelligence, and this has to be layer 3 or higher. Something like a router is smart enough to say, no, I'm not going to pass that broadcast. But it can also occur through a VLAN. Stick that in the back of your brain for now. Stick that in the back of your brain for now. So when I add some containment with layer 3 device or something with more intelligence, like layer 3 device or VLAN, I have some broadcast containment. So if I take a look at this picture again now, I see all these hub and switch here connected into a router. They have a giant bubble around the hub and switch. The router is finally smart enough to say a broadcast leaving here, the router's going to go, no, I'm not going to pass that on, go away. Okay, that's probably local traffic anyway, trying to find a printer or trying to find another node. I'm going to keep that broadcast right where it is. And the same thing is true over here. One of these nodes issues a broadcast. The switch is going to pass it on. It's going to get to the router, and the router's going to go, no, stay right where you are. Okay? So hopefully remember those two concepts. Because when I back up here, they talk about when you segment the network, each network now is its own broadcast domain. Yes, as I start breaking up the network with things like a layer 3 device, a router, or using something like a VLAN, I start segmenting my network and breaking up and doing some broadcast containment. Absolutely. This is some of the fancy names behind what's going on: collision domains and broadcast domains. As I always joke, you're not going to sit around the lunchroom and talk about them, but this is part of your network. It needs to be there. So, going back to what they're talking about now, a variety of ways to go about separating broadcast domains on a network. Layer 1, physical devices to create separate LANs. If I actually come in here and put a physical device here and break the network apart, yeah, okay. Layer 2, create VLANs with switches. Absolutely, a VLAN is going to create a broadcast domain. Or 3, using layer 3 devices or subnetting to organize the IP address space will break the network apart too into broadcast domains. Absolutely. These two being the ones that are key: VLANs and layer 3 and routers and subnetting kind of thing. Those are the big ones that are going to segment the network and break up the broadcast domains. So here they remind us, network segmentation divides a large broadcast domain into smaller ones. Absolutely. I have a large broadcast domain here. As I break the network apart with either a subnet or VLAN, I can take this large network, even this picture back here that I showed you, this network here, instead of it all just being all connected to other switches, I put a router in the middle and break it apart. And maybe this is floor 1 and this is floor 2, or maybe this is, you know, the Blocker building in Harrisburg campus, and this is the student center, you know, across the courtyard, if you will. I put a router between them to keep those traffic local in those buildings. Okay, key. All right. We're going to come back in the next podcast and start into subnets. What are subnets? And then eventually on to how we deal with them.